Tonight, we're going to explore the most frightening journey humanity has ever imagined. It begins somewhere surprisingly ordinary. A quiet room, a familiar floor beneath your feet, a single step forward every day. You cross rooms without noticing the miracle hidden inside that effortless movement. A few careful strides carry you from your bed to a window. Another handful takes you into the kitchen. The entire geography of daily life fits inside muscles, habits, and memory. Distance feels friendly. It feels tame. But outside tonight's peaceful room, distance becomes something entirely different. It becomes the oldest enemy the universe has ever invented. Imagine standing beside your front door. Behind you waits everything you have ever known. Every birthday, every conversation, every laugh, every winter morning, every summer evening. Everything that shaped your life exists within a few thousand kilometers of this place. Even the opposite side of Earth is only a long flight away. Our planet quietly teaches us that every destination can eventually become familiar. Space refuses to teach that lesson. The night sky looks gentle. Tiny lights rest upon a velvet darkness. They seem close enough to touch. Ancient storytellers connected them into hunters, queens, and monsters, and sailors trusted them. Farmers followed them. Children still point upward and wonder whether someone else is looking back. Yet appearances are patient deceivers. If you stretch one finger toward the brightest stars, that finger hides entire constellations. A single thumb held at arm's length covers thousands of suns. Your own body becomes a tiny curtain across unimaginable distances. The illusion feels comforting. Reality waits silently behind it. The nearest star beyond our sun is not simply far away. It is separated from us by a gulf so immense that language begins to lose its strength. Its name is Proxima Centauri. It belongs to the Alpha Centauri system. Together, they form our nearest stellar neighborhood. In cosmic terms, they are almost next door. Astronomers speak about them as close companions. Maps place them beside our own sun. Computer simulations often zoom smoothly between them. The transition seems effortless. Nature never makes that journey effortless. Light itself requires more than 4 years to travel between Earth and Alpha Centauri. Light, the fastest traveler our universe allows. Nothing carrying information has ever been observed moving faster. Every sunrise reaching your eyes arrives almost instantly by human standards. Sunlight leaves our star. It crosses nearly 150 million kilometers. 8 minutes later, your morning begins. 8 minutes already sounds remarkable. Now replace 8 minutes with more than 4 years. The sunlight warming another possible world near Alpha Centauri tonight will not reach Earth until children beginning school have nearly finished high school. Conversations become history before light completes the journey. The silence between stars grows larger. Scientists measure this distance as approximately 4.37 light years. The phrase sounds technical, almost harmless. But hidden inside those words lies about 41 trillion kilometers, a number too large for ordinary imagination. Zero after zero after zero, each digit quietly pushing understanding farther away. Our minds evolved differently. They evolved to judge rivers, forests, mountains, storms, the distance between shelter and danger, the walk home before darkness arrived. Evolution never prepared us for trillions, so we borrow familiar images. Imagine placing one grain of sand upon a beach, then another. Continue patiently, grain after grain. Every heartbeat adds another tiny piece, even after countless lifetimes. You would not finish counting enough grains to resemble the distances separating neighboring stars. The beach remains larger. The universe remains quieter. This is where fear slowly changes shape. Many frightening things possess clear edges. A cliff ends, a storm passes. Winter becomes spring. Even grief eventually softens beneath time's careful hands. Distance between stars behaves differently. It has no visible walls, no comforting landmarks. Only darkness. Silent, timeless, patient. Astronomers sometimes call the region beyond our solar system the interstellar medium. The name sounds almost gentle, as though it were merely another ocean awaiting brave explorers. In reality, it is thinner than any vacuum humans can create naturally upon Earth. Only a few atoms drift through each cubic centimeter. Tiny traces of hydrogen, helium, ancient dust, the fading remains of stars that died millions of years before human civilization existed. Nothing appears there, yet everything happens there. Cosmic rays race across impossible distances. Magnetic fields drift without hurry. Invisible particles travel for ages before striking another atom. Entire histories unfold without witnesses. Silence is not emptiness. Silence is simply activity moving beyond human senses. Recent astronomical observations continue reinforcing this remarkable picture rather than replacing it. Over the past months, astronomers have refined measurements of nearby stellar environments and continued examining planets around our neighboring stars. Each improvement sharpens details. None changes the fundamental truth. Interstellar space remains vast beyond ordinary comprehension. Current scientific understanding still agrees upon its overwhelming scale. Sometimes knowledge grows deeper without becoming smaller. That thought carries unexpected comfort, because every generation inherits a universe only slightly clearer than the one before. Ancient shepherds recognized bright stars. Medieval scholars mapped their positions. Modern observatories reveal planets. Powerful telescopes examine faint atmospheres. Spacecraft cross the boundary into interstellar space itself. Each century adds another careful sentence to an endless story. No chapter finishes the book. Perhaps that is fortunate. Imagine leaving Earth forever. The blue oceans shrink behind you. Continents disappear. The moon becomes another bright companion. The sun slowly transforms into one ordinary star among countless others. Nothing dramatic happens. No invisible border announces departure. There is only gradual fading. Fading can be strangely beautiful. A melody becomes quieter until memory completes the final notes. Autumn leaves drift away one by one. Evening sunlight retreats from a wooden floor. Loved voices echo long after conversations end. Space follows similar rhythms. Nothing vanishes suddenly. Everything simply grows smaller. Perhaps that is the first true lesson Alpha Centauri offers us. Terror does not always arrive with violence. Sometimes it arrives as quiet arithmetic, patient physics, numbers spoken softly enough that the heart notices them before the mind understands. Tonight's journey has barely begun. We have not built our spacecraft. We have not escaped the sun. We have not crossed the frozen darkness waiting beyond the planets. We have only taken one ordinary step across an ordinary room. Already, Earth feels smaller. Already, the nearest star seems farther than language comfortably allows, and the unsettling truth waits patiently ahead. If reaching our closest stellar neighbor already asks so much, what does that quietly suggest about every other light scattered across tonight's sky? The answer will guide our next step, one careful measure at a time, one silent year after another, one fading ray of light crossing an ocean without waves, until distance itself becomes the greatest story humanity has ever tried to tell. You have probably taken a long road trip before, perhaps across one state, perhaps across several. The highway stretched ahead like a gray ribbon. Towns appeared, then faded behind you. Gas stations became familiar islands. Rest stops marked quiet victories. Hour after hour, the landscape slowly changed. Forest became farmland, hills became plains. The destination remained somewhere beyond the next horizon. Eventually, you arrived. Every road on Earth carries that promise, no matter how distant the place feels. The journey belongs to the same world, The same sky follows overhead. The same atmosphere surrounds every breath. The same gravity quietly holds every traveler close. Now imagine driving forever. The highway never bends toward another city. No mountains appear. No ocean waits beyond the next ridge. The road simply continues through perfect darkness. Even that image fails, because a highway implies nearby destinations. Interstellar space offers none. The distance to Alpha Centauri is about 4.37 light-years. Scientists often write the number with calm precision. It appears inside textbooks, research papers, telescope databases. Yet numbers have a curious habit. They become quieter as they become larger. Your mind easily understands 10 meters. A football field requires only a little more imagination. 1,000 kilometers begins to feel abstract. 41 trillion kilometers almost slips beyond thought entirely. So let us slow down. Imagine standing beside an old railroad track. A train rolls past at 60 kilometers each hour. It feels steady, comfortable. You wave as it disappears into the distance. If that train never stopped, if it never slowed, if it never required repairs, if generations lived and died while it continued, it would still need tens of millions of years to reach Alpha Centauri. The train becomes absurd, yet the stars remain unchanged. Perhaps airplanes feel more suitable. A modern passenger jet cruises around 900 kilometers each hour. It crosses oceans overnight. It connects continents before breakfast. It makes Earth feel wonderfully small. But if that aircraft somehow continued without landing, without fuel shortages, without mechanical failure, it would require well over 5 million years to arrive. 5 million years. When that journey began, our own species did not yet exist in its modern form. Ancient human ancestors still wandered African landscapes. Stone tools remained simple. Language, as we know it, had not yet matured. The airplane would still be flying today. Distance quietly defeats speed. This is where the imagination begins to drift. Astronomers avoid kilometers whenever possible. The numbers become inconvenient. Instead, they use light years. Not because light years are small, because kilometers are simply too large. A light year is the distance light travels during one Earth year. Light moves about 300,000 kilometers every second. Every second. Before you finish reading this sentence, light has already circled Earth more than 7 times. That speed feels almost magical. Yet even light requires over 4 years to bridge the gap toward Alpha Centauri. Physics speaks softly. Its conclusions remain absolute. There is another way to picture this journey. Imagine shrinking our solar system. Suppose the sun becomes a small orange sitting upon your kitchen table. Earth would shrink into a tiny grain, barely visible, only a short distance away. Jupiter would rest somewhere across the room. Neptune might stand near the front door. The entire solar system would comfortably fit inside your home. Where would Alpha Centauri appear? Not in another room, not across your neighborhood, not even within your city. That second orange would stand thousands of kilometers away, perhaps across an ocean. The empty space between those two oranges would contain almost nothing. Almost. Tiny atoms drift there. Invisible dust, ancient magnetic fields, cosmic rays carrying impossible energies, fragments from long-dead stars. The darkness is never completely empty. It merely whispers instead of speaking. Modern spacecraft help us appreciate this silence. The Voyager probes left Earth nearly half a century ago. They have crossed the outer boundary of our solar system. They now travel through interstellar space itself. This achievement sounds astonishing. It truly is. Yet Voyager 1 has covered only a tiny fraction of the distance toward Alpha Centauri. If pointed directly toward our neighboring stars, it would still require roughly 70,000 years to arrive. 70,000 years. When Voyager finally approached its destination, if it somehow survived, every civilization alive today would belong to unimaginably ancient history. Languages would change. Continents might shift slightly. Entire cultures would rise, disappear, be forgotten. The spacecraft would continue drifting, silent, faithful, unaware that its creators had become fossils long ago. There is something strangely peaceful about that image. Human ambition often measures success within years, sometimes decades. The cosmos patiently measures it differently. Thousands, millions, billions. It never hurries. Perhaps we should not hurry either. Recent astronomical research has continued refining the distances and motions of nearby stars with extraordinary precision. Missions like Gaia have measured stellar positions so accurately that astronomers can predict future movements across the sky with remarkable confidence. Yet, these improvements have not made Alpha Centauri meaningfully closer. Better measurements sharpen our maps. They do not shorten the road. Knowledge expands. Distance remains. That distinction matters. Science does not exist to comfort us, nor does it exist to frighten us. Its purpose is gentler, to replace illusion with understanding. Sometimes understanding feels smaller. Sometimes it feels immeasurably larger. Tonight, it does both. Consider one final comparison. Imagine every second becoming a single step. 1, 2, 3. Each heartbeat moves you forward once, without sleeping, without resting, without stopping. You continue stepping every second. To count 4 years this way would already test human endurance beyond possibility. Now imagine stepping once every second for 4 entire years, simply to imitate the travel time of light itself. Not your travel time. Light's the fastest messenger the universe allows. Suddenly, the night sky changes. Those stars no longer resemble decorations. They become archives. Every point of light arrives carrying history. Some left before today's children were born. Others departed centuries ago. Still others began their journey before humanity discovered agriculture. Looking upward quietly becomes looking backward. The sky transforms into memory. Alpha Centauri shines tonight exactly as it appeared more than 4 years ago. Whatever happens there this evening remains unknown to us. Its newest light has not yet arrived. It is still crossing the great darkness, still racing through silent space, still carrying news from another sun. That realization introduces a new obstacle, even if distance could somehow be conquered. Another question quietly waits ahead. How fast could we truly travel, and what price would physics demand for every additional kilometer each second? That answer begins where every journey eventually does, with the desperate desire to move faster. You have probably watched an airplane disappear into the clouds. It begins with a roar. The engines awaken. The runway trembles. Buildings slowly slide backward through the window. Then comes the gentle lift, almost unnoticed. Earth quietly releases its grip. Roads become threads. Rivers become silver ribbons. Entire cities shrink beneath a blanket of clouds. For a brief moment, it feels impossibly fast. Hours later, another continent appears. Human history has been shaped by this feeling. Every generation has celebrated greater speed. Horses replaced walking. Steam engines replaced horses. Aircraft replaced ships. Rockets escaped the atmosphere itself. Each breakthrough made the world feel smaller than it had the century before. Progress became a race. The finish line always seemed within reach. Space changes the rules. The airplane cruising peacefully above the clouds travels around 900 kilometers each hour. A military jet may fly several times faster. The fastest crewed aircraft ever built briefly exceeded 7,000 kilometers per hour. Remarkable achievements. Each one pushed engineering toward its limits. Each one transformed civilization. None of them truly matters once the destination becomes another star. Imagine pointing that fastest aircraft directly toward Alpha Centauri. Its engines never fail. Its fuel never runs out. Its pilots never grow tired. It continues endlessly through the silent darkness. Even then, the journey would require hundreds of thousands of years. The numbers quietly erase the achievement. This is one of the strangest lessons in astronomy. Something can be unimaginably fast and simultaneously hopelessly slow. The contradiction feels uncomfortable because our instincts evolved differently. On Earth, doubling your speed changes everything. Drive twice as fast. You arrive in half the time. Fly twice as fast. The ocean becomes much smaller. Physics seems generous. Interstellar space is not. Every increase in speed demands a greater price than the one before. The first rockets were difficult. The next generation became even harder. Reaching orbit required astonishing precision. Escaping Earth's gravity demanded still more energy. Leaving the solar system required even more. The farther we reach, the steeper the mountain becomes. There is a simple image that helps explain why. Imagine pushing a child on a swing. The first gentle push is easy. To make the swing rise higher, you push harder to send it almost over the top. Every new push demands much more effort. The increase is no longer gentle. Energy grows faster than intuition expects. Spacecraft behave the same way. A little more speed requires much more energy. Much more speed requires astonishing amounts. Approaching the speed of light becomes an almost unimaginable challenge. Albert Einstein revealed why more than a century ago. His theory of special relativity quietly transformed the universe. Not because it made space stranger, because it revealed that space had always been strange. Light occupies a unique place in nature. It is not merely very fast. It defines the ultimate speed limit of our universe. Nothing carrying information has ever been observed exceeding it. Every experiment, every observation, every successful prediction has reinforced that remarkable conclusion. As an object moves faster, adding still more speed becomes increasingly difficult. Its energy climbs dramatically. Closer, closer, ever closer to light, yet never beyond. The limit remains patient, silent, unmoved. Imagine climbing a mountain whose summit slowly rises every time you approach it. You climb harder. The peak climbs too. You gain altitude. The summit remains just beyond reach. That mountain is the speed of light. Physics does not forbid climbing. It simply refuses to lower the summit. This realization has shaped every serious proposal for reaching Alpha Centauri. Chemical rockets cannot do it within human lifetimes. Their fuel carries too little energy. Ion engines work efficiently, but produce tiny thrust. Nuclear concepts promise greater performance, yet introduce immense engineering challenges. Each solution opens another question. Each answer creates another obstacle. Recent research continues exploring several remarkable possibilities. One of the most ambitious is Breakthrough Starshot. Instead of building one enormous spacecraft, the idea proposes something radically different. Tiny probes, each weighing only a few grams. Powerful lasers stationed near Earth would illuminate enormous reflective sails. The pressure of light itself would provide acceleration. No fuel carried on board. Only photons, tiny packets of light, pushing gently, continuously, like wind filling an invisible sail. If such technology succeeds, these miniature spacecraft might reach around 20% of light speed. That sounds extraordinary. It truly is. Yet even then, the voyage would still require roughly 20 years. 20 years for a probe no heavier than a paperclip. Not a crew, not a family, not a civilization, only a tiny robotic messenger racing through darkness. The idea remains under development. Its engineering challenges are immense. Building lasers powerful enough, keeping the sail stable, protecting delicate electronics from dust, moving at relativistic speeds. Every key detail demands solutions humanity has not yet demonstrated at full scale. It is hope, not certainty. Science carefully distinguishes between possibility and achievement. That distinction protects discovery from fantasy. Meanwhile, other researchers continue studying nuclear fusion propulsion. Fusion powers the stars themselves. If humanity could reliably harness it for spacecraft, entirely new possibilities might emerge. Experiments on Earth have advanced steadily. Important milestones have been reached. Yet practical fusion propulsion remains a future ambition rather than an operational reality. The dream survives, patiently, like many scientific dreams before it. Speed always carries another hidden cost. Imagine driving through heavy rain. At walking pace, raindrops barely sting. At highway speed, each drop strikes with surprising force. Now imagine traveling at 1/5 the speed of light. Tiny grains of interstellar dust become dangerous projectiles. Atoms themselves carry tremendous energy upon impact. The emptiness between stars suddenly feels crowded, not because there is much there, because your own speed transforms almost nothing into something significant. Motion changes reality. That idea feels strangely poetic. The faster we chase distant horizons, the more the quiet darkness pushes back. Perhaps every great journey contains this lesson, not only among the stars, within life itself. The quickest path is rarely the gentlest. The greatest ambitions demand the greatest patience. Some destinations refuse to be conquered by urgency. They ask instead for endurance, for careful planning, for generations willing to continue work they may never finish. Tonight, Alpha Centauri still waits, unchanged. Its light continues crossing the darkness. Its planets, if present, continue orbiting unseen. Its ancient stars burn with patient indifference. We are the ones who hurry. The stars never do. And so another question quietly emerges. If speed alone cannot rescue us, if even light takes years to arrive, then perhaps the true challenge is no longer moving faster. Perhaps it is building a vessel capable of surviving the longest voyage humanity has ever imagined. You have probably watched a ship being built, perhaps only in a documentary, perhaps beside a quiet harbor. It begins with almost nothing. Steel beams, wooden frames, empty scaffolding. Workers move slowly between unfinished walls. At first, it hardly resembles a vessel at all. It looks more like an unfinished building than something destined to cross an ocean. Day after day, another piece appears, a deck, a cabin, an engine, a bridge. Eventually, almost without noticing, the collection of parts becomes a ship. Then one morning, it meets the water. Interstellar spacecraft must begin the same way, only every familiar assumption quietly disappears. A ship crossing the Atlantic expects rescue if something fails. Another vessel may answer. A helicopter may arrive. Land is never impossibly distant. An interstellar ship receives no such promise. There are no coast guards between the stars, no nearby ports, no emergency harbors, only silence. The first challenge is surprisingly simple. What exactly should we build? If the journey lasted 20 years, perhaps a small crew might survive. If it lasted 50 years, every kilogram of food would matter. If it lasted centuries, the question changes completely. The ship no longer carries passengers. It carries a civilization. This idea gave birth to one of the oldest concepts in interstellar engineering, the generation ship. Imagine constructing not merely a spacecraft, but a tiny world. Children would be born aboard. They would grow old aboard. Their grandchildren might never see Earth. Neither would their great-grandchildren. For them, the ship would not be transportation. It would simply be home. The destination would become a story told by distant ancestors, rather like ancient legends told around a fireplace. Except this legend would point toward another sun. The engineering quickly becomes overwhelming. A generation ship cannot rely upon frequent supplies. Everything must recycle. Every drop of water, every breath, every atom possible. Nature already demonstrates such systems beautifully. Earth itself has quietly recycled the same water for billions of years. The rain falling tonight may once have drifted through ancient forests. It may have rested inside glaciers. It may have passed through dinosaurs. Nothing truly disappears. It changes form. A spacecraft must imitate that elegance. Closed ecological systems have fascinated scientists for decades. Plants become more than food. They become partners. They absorb carbon dioxide, release oxygen, purify water, recycle waste. Every leaf becomes part of the life support system. The ship slowly resembles a forest wrapped inside metal. The people aboard would depend upon biology as much as machinery, perhaps even more, because machines eventually wear out. Living systems repair themselves, quietly, patiently, every sunrise. There is another comforting image. Think about an old grandfather clock. It continues ticking for generations because someone winds it, someone oils its gears, someone replaces worn parts. Maintenance becomes tradition. An interstellar ship would require exactly that spirit, not for decades, for centuries. Every generation would inherit countless responsibilities. Repair this reactor, Inspect these pipes, replace these bearings, calibrate these sensors. The smallest neglected task might someday threaten everyone aboard. Routine becomes survival. History offers an interesting parallel. The great medieval cathedrals of Europe often required centuries to complete. The builders who laid the foundations knew they would never witness the finished towers. Their grandchildren continued the work, then another generation, then another. Faith stretched farther than individual lifetimes. Interstellar travel demands a similar mindset, not religious faith, but civilizational faith, the belief that some achievements deserve completion, even if those who begin them never arrive. That may be one of humanity's rarest strengths, to plant trees beneath whose shade we never expect to rest. Yet even the finest generation ship faces another quiet enemy. Population. Too few people. Genetic diversity declines. Skills disappear. One accident becomes catastrophic. Too many people. Resources vanish. Food becomes scarce. Every birth, every harvest, every repair must remain balanced with extraordinary care. The spacecraft slowly resembles an entire society compressed into a floating island. Economics follows. Education follows. Law follows. Music follows. Art follows. Even laughter becomes essential. Because survival alone rarely satisfies the human heart. Psychologists often remind us that meaning can become as important as food. Imagine being born aboard such a vessel. You have never seen rain, only carefully managed water. You have never watched birds crossing an open sky, only maintenance drones moving through long corridors. Your grandparents spoke of oceans. You have only recordings. Would Earth still feel like home, or merely mythology? That question carries surprising weight, because home is not always where we began. Sometimes home becomes wherever memory feels strongest. Modern engineers occasionally study concepts far smaller than generation ships. Breakthrough Starshot envisions tiny robotic probes. Other proposals examine nuclear electric spacecraft, fusion-powered designs, antimatter ideas, even exotic concepts involving beam propulsion. Each attempts to avoid the enormous burden of carrying an entire civilization. Each offers advantages. Each introduces new limitations. There is still no accepted blueprint for sending humans safely to Alpha Centauri. Current scientific understanding remains unchanged. The challenge is engineering, not imagination. Imagination arrived decades ago. Reality simply asks much more. One fascinating proposal involves suspended animation instead of maintaining generations. Perhaps travelers might sleep, not ordinary sleep, something far deeper, a biological pause. Many animals already demonstrate remarkable versions of this strategy. Bears slow their metabolism. Tiny tardigrades survive extraordinary environments. Certain frogs endure freezing temperatures. Nature experiments continuously. Human medicine has explored therapeutic hypothermia for specific clinical situations. Researchers continue investigating longer duration metabolic suppression. Yet true human hibernation remains experimental. No verified technology today allows centuries of safe, suspended animation. The dream persists. The evidence remains incomplete. Science carefully separates hope from capability. Perhaps that restraint is one of its greatest virtues. There is another obstacle quietly waiting. Even the strongest ship eventually ages. Metal becomes brittle. Radiation slowly damages electronics. Microscopic impacts accumulate. Lubricants degrade. Seals weaken. Time behaves like invisible seawater. Everything immersed within it slowly changes. Imagine carrying your favorite watch every day for 200 years. Impossible. Not because the watch was poorly built, because time eventually reaches every mechanism. A starship is no different. Its greatest enemy may not be distance or speed, but simple persistence. Can anything humans build continue functioning for centuries without outside assistance? Some spacecraft already surprise us. Voyager continues communicating after nearly 50 years, far longer than originally expected. Its endurance inspires engineers, yet 50 years remain only the first chapter of an interstellar voyage. The story stretches much farther, perhaps farther than any machine humanity has yet created. And still, suppose every engineering problem is solved. Suppose the ship survives. Suppose generations flourish. One final question quietly waits beyond every technical drawing. What happens when the familiar warmth of the sun finally disappears behind the endless darkness? That moment changes everything, because leaving Earth is only the beginning. Leaving the solar system is the true farewell. You have probably watched a sunset without thinking it might be the last one you would ever see. The sky slowly changed from blue to gold, then amber, then deep violet. Shadows stretched across familiar ground. Birds disappeared into distant trees. Streetlights quietly awakened. Nothing about the moment suggested permanence. You knew the sun would return tomorrow. That quiet certainty has accompanied every human life ever lived, even during history's darkest wars, even through storms and famines. Morning always arrived. Imagine, then, the first crew leaving the solar system and realizing there would never again be another earthly sunrise. The sun would still exist. It would still burn with astonishing power. But it would no longer dominate the sky. It would slowly become another distant star among countless others. The transformation would not happen in a single dramatic moment. Space rarely offers theatrical endings. Earth would first shrink into a pale blue point. The moon would disappear beside it. The great planets would slowly scatter behind the spacecraft, like forgotten milestones along an endless road. Jupiter, once a magnificent striped giant, would eventually become another bright speck. Saturn's beautiful rings would vanish long before Saturn itself became invisible. Uranus and Neptune would quietly fade into darkness. Every familiar landmark of childhood astronomy would surrender to distance. Not suddenly, patiently, this gradual disappearance reveals something profound about the human mind. We often imagine important moments arriving with unmistakable certainty. We expect music, celebration, final words. Reality usually whispers instead. You rarely remember the last time you climbed a favorite childhood tree. You rarely recognize the final conversation before someone moves away forever. The solar system would disappear the same way. One ordinary observation, one routine instrument check. Then another day arrives. At some point, without anyone noticing. Home becomes too small to recognize. There exists an invisible frontier called the heliopause. It marks the region where the outward flow of charged particles from our sun finally yields to the pressure of interstellar space. It is not a wall. It is not a gate. It resembles two gentle ocean currents meeting beneath the surface. Voyager 1 crossed this region in 2012. Voyager 2 followed several years later. Humanity quietly entered interstellar space without fireworks. The spacecraft reported subtle changes in magnetic fields, different particle populations, a shift almost invisible to human senses, yet scientifically. It represented one of our greatest milestones. For the first time, machines built by human hands began directly sampling the environment between the stars. The word interstellar sounds dramatic. The measurements feel remarkably calm. Particle densities changed. Plasma behaved differently. Magnetic field orientations shifted. Nature did not announce the crossing with thunder. Physics almost never does. The universe prefers quiet transitions. Imagine floating down a wide river. The current beneath your boat slowly changes direction. The water looks almost identical. The sky remains unchanged. Birds continue flying overhead. Yet beneath the surface, you have entered another watershed entirely. The heliopause behaves much the same way. Invisible boundaries often carry the greatest significance. Beyond this frontier, sunlight begins losing something deeply familiar. Near Earth, sunlight defines everything. It warms oceans, powers forests, paints clouds with color, shapes our circadian rhythms. Every heartbeat indirectly depends upon ancient sunlight stored inside plants. Animals, and food. As a spacecraft travels farther away, the brightness declines according to one of physics' simplest rules. Double the distance, light falls to 1/4. 10 times farther, only 1/100th remains. By the time travelers approach the distant outskirts of the solar system, the sun resembles an extraordinarily bright star rather than an overwhelming presence. Shadows soften, warmth fades, solar panels become increasingly impractical. Nuclear power quietly assumes the burden. The darkness between stars is not perfectly black. Starlight still drifts across unimaginable distances. The faint glow of the Milky Way stretches overhead. Distant galaxies contribute almost imperceptible illumination. Yet, none of it resembles daylight. It is enough to remind you that other suns exist, not enough to replace your own. This realization carries emotional weight beyond engineering. Human beings evolved beneath one particular star. Every story ever written, every civilization ever built, every piece of music, every language, every act of kindness, every mistake, every triumph, all unfolded beneath the same yellow sun. Leaving it behind is not merely geographical. It is psychological. The familiar rhythm that quietly shaped human existence begins dissolving into memory. Astronauts aboard the International Space Station often describe looking back at Earth with unexpected emotion. The planet appears delicate, borders disappear, arguments seem strangely temporary, distance alters perspective. An interstellar traveler would experience that transformation many times over. First, Earth becomes fragile. Then the solar system itself becomes fragile. Finally, even the sun joins the countless anonymous lights scattered across the night. Recent observations continue reinforcing how dynamic our heliosphere truly is. Data from Voyager, IBX, and newer heliophysics research show that the boundary surrounding our solar system subtly responds to changing solar activity and the surrounding interstellar environment. Scientists continue refining models of this interaction. Yet, the essential understanding remains stable. The sun's protective bubble extends astonishingly far, but it is not infinite. Eventually, every traveler leaves its embrace. There is something quietly beautiful about that image. Imagine standing beneath a giant tree at dusk. Throughout childhood, its branches sheltered every season of your life. One day, you begin walking away. The tree does not shrink because it changes. It shrinks because you do. Eventually, it becomes another silhouette upon the horizon. The memories remain full-sized. Only the tree becomes small. Perhaps that is what happens with home. It never truly grows distant inside memory, only inside space. The farther the spacecraft travels, the more communication delays quietly lengthen. Radio signals no longer cross the solar system in minutes. Instructions require hours, then longer. Eventually, conversations become correspondence rather than dialogue. Questions cannot be answered immediately. Decisions increasingly belong to those aboard. Independence arrives not through declaration, but through physics. Every solution quietly introduces another obstacle. Escaping the sun solves the problem of departure. Yet, it exposes travelers to a far older environment. Beyond the heliosphere waits a region almost unimaginably empty, yet filled with invisible radiation. Ancient dust, wandering magnetic fields, and particles accelerated by violent events across the galaxy. Leaving home is complete. Surviving what lies beyond has only just begun. The darkest place you have probably ever walked was still full of life. Perhaps it was a forest after sunset, a quiet country road, a beach beneath a moonless sky. At first, the darkness seemed complete. Then your eyes slowly adjusted. The outline of trees returned. The horizon appeared. The sound of insects filled the silence. Somewhere nearby, leaves rustled. A breeze touched your face, even in near darkness. Earth never allows you to feel completely alone. Interstellar space offers a different kind of darkness, not because it lacks light, but because it lacks familiarity. The region between the stars is often imagined as an enormous empty vacuum. Movies frequently portray spacecraft gliding effortlessly through a perfectly black ocean. The reality is subtler. Space between stars contains gas, dust, magnetic fields, high-energy particles, ancient debris from exploding suns. It is astonishingly thin. Yet across trillions of kilometers, even the thinnest environment begins to matter. Imagine driving through a light mist at walking speed. You barely notice it. At highway speed, tiny droplets begin striking the windshield with surprising force. Now imagine traveling at 1/5 the speed of light. A microscopic grain of dust, smaller than a grain of sand, suddenly carries the energy of an explosive projectile. The dust itself has not changed. Your speed has transformed its harmlessness into danger. Motion changes everything. Astronomers estimate that interstellar space contains countless microscopic dust grains drifting silently through the galaxy. Most are unimaginably small. Fragments of ancient stars, tiny crystals forged inside stellar atmospheres billions of years ago, invisible to human eyes. Yet during an interstellar journey, they become one of the greatest engineering challenges ever imagined. Every second, another impact, then another. Most would be insignificant, some would not. Protecting a spacecraft, traveling at relativistic speed, may require massive forward shields, magnetic deflection systems, or sacrificial layers designed to erode gradually over decades. Engineers continue studying these possibilities. There is no universally accepted solution today. Every answer creates another question. Behind the dust comes radiation. On Earth, our atmosphere quietly performs an extraordinary service. Above us stretches a protective blanket almost 100 kilometers thick. Above that, Earth's magnetic field gently bends many charged particles away from the surface. Most people never think about these invisible guardians. We simply step outside, feel the sunlight, breathe deeply. The dangerous particles streaming across the galaxy mostly pass unnoticed. Space removes that protection. Beyond the heliosphere, cosmic rays arrive from every direction. Some began their journeys inside exploding supernovae. Others may have been accelerated near black holes or other energetic environments. Many travel for millions of years before encountering anything at all. Eventually, they encounter your spacecraft. These particles move astonishingly fast. Some carry energies far beyond anything produced by human-made particle accelerators. When they strike shielding, they can generate showers of secondary particles. Protecting human tissue during a journey lasting decades or centuries remains one of the greatest unsolved problems of interstellar travel. There are promising ideas: hydrogen-rich materials, water shielding, magnetic protection, advanced composite structures. Each offers advantages. Each introduces weight. Weight demands more energy. More energy requires larger spacecraft. Larger spacecraft demand even more energy still. The circle quietly closes again. Nature seems determined to remind us that simplicity rarely survives among the stars. Yet radiation is not the only invisible companion. The local interstellar cloud surrounds our solar system today. It is a vast region of thin gas drifting through the Milky Way. Our sun moves through it as both travel around the center of the galaxy. The cloud is not dense, far from it, but its existence reminds us that even empty space possesses structure. The galaxy has weather, not rain, not wind as we know it, but enormous flows of gas, expanding shock waves, magnetic turbulence, regions warmer, regions cooler, clouds larger than entire planetary systems. Everything moves, only very slowly. Recent heliophysics research continues refining our understanding of this nearby interstellar environment using data from Voyager. IBEX, and other missions. Scientists have improved models of how our heliosphere interacts with surrounding interstellar gas. These observations strengthen existing theories rather than overturn them. The neighborhood between the stars remains dynamic, subtle, and far from perfectly uniform. Imagine floating upon an ocean at night. The surface appears calm, yet beneath your boat, powerful currents slowly reshape entire coastlines. The sea remains quiet. Its motion never truly stops. Interstellar space behaves much the same way. Silence often hides movement. There is another danger that receives less attention. Loneliness, not emotional loneliness, physical loneliness. Suppose something breaks, a valve fails, a sensor malfunctions, a cooling pump stops. On Earth, replacement parts can be delivered. Experts can be called. Factories can manufacture new components. Between the stars, every tool you will ever need must already be aboard. Every mistake becomes permanent. Self-repair becomes essential. Future spacecraft may rely heavily upon autonomous manufacturing. Three-dimensional printing has already demonstrated remarkable flexibility aboard orbital missions. Future technologies might recycle damaged materials into replacement components. Artificial intelligence could diagnose failures long before human crews recognize them. These ideas remain active fields of research, encouraging, but unfinished. Interstellar engineering continues to live partly inside laboratories, partly inside imagination. The two slowly approach one another. Perhaps they always have. Every major technological achievement once seemed unrealistic. Crossing oceans, flying, walking upon the moon. Each generation inherits impossibilities from the one before, then quietly removes one from the list. Still, Alpha Centauri asks for something greater than any previous challenge. Not merely invention, persistence. Imagine carrying a candle through a vast cave. You shield the flame with careful hands. Each gentle step matters. One careless movement ends the light. A spacecraft crossing interstellar space resembles that fragile candle, not because it is weak, because the darkness surrounding it is unimaginably patient. Year after year, the vessel continues. Dust taps softly against its shield. Radiation quietly passes through layers of protection. Microscopic cracks slowly grow. Computers monitor thousands of systems without applause. The voyage becomes a meditation in endurance. Perhaps that is why space feels so deeply philosophical. It rewards neither haste nor arrogance, only consistency, only careful attention repeated over extraordinary lengths of time. A forest grows that way. Stone mountains erode that way. Civilizations rise that way. The stars themselves burn that way, slowly, quietly, without announcing each passing century. As the spacecraft drifts deeper into the interstellar darkness, another transformation begins. The greatest challenge is no longer outside the hull. It begins inside, because even if every machine survives, even if every shield holds, even if every system performs perfectly, time itself will begin changing the people making the journey. And that change may prove more profound than anything waiting among the stars. Take a moment to think about an old family photograph. Perhaps it rests inside a drawer. Perhaps it hangs quietly on a wall. The faces inside that picture never change. They continue smiling exactly as they did years ago. Yet, every time you look at it, you are different. Your memories have grown. Your life has moved forward. The photograph remains still while time quietly reshapes the person observing it. Space travel carries a similar paradox. The farther humanity journeys from Earth, the more time itself becomes something to question rather than simply experience. On Earth, time feels dependable. Morning follows night. Spring follows winter. Birthdays arrive one after another with comforting regularity. Clocks tick at the same pace, whether they hang in a crowded city or a quiet farmhouse. We naturally assume that time behaves identically everywhere for ordinary human life. That assumption works remarkably well. The universe, however, tells a more subtle story. Albert Einstein showed that space and time are woven together into a single fabric. Motion through space influences the passage of time itself. This idea seems almost impossible when first encountered, yet more than a century of experiments has repeatedly confirmed it. Atomic clocks flown aboard aircraft measure tiny differences. Satellites orbiting Earth must continuously account for relativistic effects. Without those corrections, modern GPS navigation would slowly become inaccurate. Relativity is not philosophical speculation. It quietly supports technologies millions of people use every day. Imagine two perfectly identical clocks. One remains inside your home. The other boards a spacecraft capable of extraordinary speed. When the travelers eventually reunite, the clocks no longer agree perfectly. The moving clock has experienced slightly less time. The effect is tiny at ordinary speeds. It becomes significant only as velocity approaches the speed of light. This phenomenon is called time dilation. The phrase sounds technical. The emotional reality feels much deeper. Suppose one day, humanity develops a spacecraft capable of traveling at 90% of light speed. Such technology lies far beyond current engineering, but physics allows us to imagine it. For those aboard, the voyage toward Alpha Centauri would seem noticeably shorter than observers remaining on Earth would calculate. Their biological clocks would continue ticking normally from their own perspective. Meals would still follow breakfast. Conversations would still unfold naturally. Heartbeats would feel unchanged. Yet Earth would experience more time than they do. The travelers would not notice time slowing. Everyone else would notice time advancing. This is one of the gentlest and most unsettling truths modern physics has revealed. Time is not a universal river flowing identically for every observer. It bends with motion. It stretches with gravity. Reality proves more flexible than intuition ever prepared us to accept. Imagine two friends beginning a walk together. One follows a straight path across an open meadow. The other climbs a winding mountain trail. Both keep walking. Both grow tired. Both eventually reach the end. Yet the journeys required different distances. Relativity suggests something similar about time itself. Different paths through the universe produce different experiences of duration. The mathematics describing this behavior has survived every serious experimental challenge. It remains one of the strongest foundations of modern physics, even without relativistic travel. Interstellar voyages quietly separate generations. Consider a mission lasting 100 years. The crew departing Earth waves goodbye to parents who will never see them again. Children born aboard the vessel inherit stories instead of memories. Great-grandchildren may know Earth only through recordings. History gradually replaces experience. The emotional distance begins growing long before the physical destination is reached. Letters become archives. Voices become historical documents. Birthdays become impossible to celebrate together. Imagine receiving a message from someone you love. The signal traveled 4 years before reaching you. You answer immediately. Your reply requires another 4 years. A simple conversation now spans nearly a decade. Questions become carefully chosen. Silences become unavoidable. The speed of light itself transforms relationships. Physics quietly dictates the rhythm of human emotion. This realization has influenced scientists studying future interstellar communication. No technology known today allows information to outrun light. Every realistic mission must accept that conversations with Earth gradually become slower until they resemble exchanges between distant centuries rather than ordinary dialogue. Recent research has not overturned this understanding. New experiments continue testing relativity with extraordinary precision using atomic clocks, satellite observations, and astronomical measurements. Each refinement strengthens confidence in Einstein's framework across increasingly demanding conditions. Scientists continue exploring deeper theories that might someday unite relativity with quantum mechanics. But no verified observation has challenged relativity's predictions for travel between stars. Sometimes, the oldest ideas remain the strongest. Not because they resist questioning, because they survive it. There is another form of time that no equation fully describes: psychological time. An hour spent waiting often feels longer than an hour spent laughing with friends. A quiet winter evening may seem endless. A joyful holiday disappears almost instantly. Human consciousness measures duration differently from clocks. Now imagine living aboard a spacecraft for decades. The same corridors, the same lights, the same carefully maintained gardens, the same familiar faces. Days slowly merge into weeks, weeks into years. Routine becomes both comfort and confinement. Time may begin losing its sharp edges. Astronauts aboard long-duration missions already describe subtle changes in perception. Without familiar weather, changing seasons, or ordinary social rhythms, the calendar becomes something maintained deliberately rather than experienced naturally. Future interstellar travelers may rely upon artificial seasons, scheduled celebrations, and carefully designed environments simply to preserve a healthy sense of passing time. The ship itself might become a giant clock. Lights brighten each morning, dim each evening. Gardens bloom according to programmed cycles. Music marks anniversaries. Children celebrate traditions created aboard rather than inherited from Earth. Culture continues evolving, because culture always travels with people, even into the darkness between stars. Perhaps this is one of humanity's quietest strengths. We do not merely survive new places. We create meaning within them. A fireplace becomes home. A small garden becomes hope. A shared meal becomes continuity. Distance cannot easily erase those things. Yet every solution gently introduces another obstacle. Even if travelers preserve their calendars, even if relativity is understood, even if communication somehow remains meaningful across years of delay, one question grows heavier with every passing decade. How does the human mind endure knowing that the world it left behind continues changing without it? That answer belongs not to physics, but to memory, and memory may prove the most fragile cargo aboard the entire voyage. Have you ever awakened in the middle of the night and needed a few quiet seconds to remember where you were? The room felt familiar, yet strangely distant. The ceiling looked different in the darkness. The silence seemed heavier than usual. Then, almost gently, memory returned. You remembered your home, your life, your place in the world. That brief moment of uncertainty rarely lasts more than a few heartbeats. Yet, it reveals something remarkable. Human identity depends upon familiar surroundings far more than we usually notice. Now imagine waking aboard a spacecraft, not for one night, not for 1 year, but for an entire lifetime. Outside the window, nothing changes. No seasons arrive. No rain touches the hull. No birds announce the morning. No distant mountains slowly gather snow. The stars remain almost perfectly fixed. Week after week, year after year, the universe becomes astonishingly beautiful and astonishingly repetitive. The greatest challenge may no longer be surviving space. It may be surviving sameness. On Earth, change quietly protects the human mind. Morning sunlight enters from slightly different angles throughout the year. Trees grow leaves, then lose them. Cities expand. Children become adults. Even familiar neighborhoods slowly evolve. These subtle transformations reassure us that time continues flowing. A spacecraft removes many of those gentle reminders. Its corridors remain unchanged because they must. Its air remains carefully controlled. Its temperature barely fluctuates. Its routines become almost perfectly predictable. Engineers would celebrate such stability. Psychologists would examine it much more carefully. Modern space agencies have already learned valuable lessons from astronauts spending months aboard orbiting laboratories. Isolation does not simply mean being alone. It means living within a limited social world. The same voices, the same responsibilities, the same environment repeated continuously. Even highly trained crews occasionally report changes in mood, attention, sleep patterns, and emotional resilience. These experiences provide important insight into future missions far beyond Earth. Interstellar travel magnifies every one of those challenges. Imagine reading every book aboard your ship. Eventually you finish. You begin again. Imagine walking the same hallway 10,000 times. You know every scratch upon every wall, every gentle vibration, every familiar sound. Comfort slowly blends with monotony. The human brain evolved inside environments filled with novelty, new landscapes, new faces, unexpected events. Curiosity helped our ancestors survive. Between the stars, curiosity encounters fewer new objects, so it quietly turns inward. People begin asking different questions. Who will remember Earth correctly? Which traditions deserve preserving? Should children born aboard continue following calendars created beneath another sun? What does the word home actually mean? These questions possess no engineering solution. They belong to philosophy, to culture, to memory. Imagine a young child born aboard the vessel asking a simple question. What does rain smell like? No scientific explanation truly answers. You may describe water droplets striking warm soil. You may explain petrichor, the oils released by plants, the compounds produced by bacteria. Every chemical detail may be perfectly accurate, yet the experience remains absent. Some things cannot be transmitted through information alone. They must be lived. That realization carries quiet sadness. Each generation aboard an interstellar vessel would inherit fewer direct memories of Earth. The first generation remembers forests. The second remembers stories. The third remembers recordings. Eventually, Earth risks becoming less like history, more like mythology. Civilizations have experienced similar transformations before. Ancient cities disappeared beneath sand. Languages faded. Songs survived after their original meanings were forgotten. The details changed. The emotions remained. Perhaps Earth itself would slowly become such a legend, a beautiful place beneath a yellow sun, filled with oceans, clouds, birdsong, wind. Children might listen with wonder, not disbelief, simply distance. Psychologists studying long-duration isolation often emphasize the importance of shared purpose. Human beings tolerate hardship more effectively when suffering possesses meaning. Explorers crossing polar ice, sailors rounding dangerous capes, researchers wintering in Antarctica. Each accepts discomfort because the destination matters. Purpose becomes psychological shelter. An interstellar crew would need that shelter constantly. Every repair, every lesson taught to children, every carefully tended garden, every celebration, each becomes another reminder. We are traveling for someone, perhaps for ourselves, perhaps for descendants we will never meet, perhaps simply because humanity has always walked toward distant horizons. Recent behavioral research connected with space exploration continues examining group dynamics, isolation, and cognitive performance in confined environments. Scientists use Antarctic stations, underwater habitats, and long-duration simulation facilities to better understand how small communities adapt across extended periods. These studies consistently suggest that technical excellence alone cannot guarantee mission success. Emotional resilience, flexible leadership, meaningful routines, and strong social bonds appear equally essential. Machines sustain life. Relationships sustain people. The distinction may determine whether a mission survives. Imagine tending a small tree inside the spacecraft. You plant it as a seedling. Years pass. Its branches slowly spread beneath artificial light. Children climb beside it. Grandchildren rest beneath its leaves. The tree quietly becomes older than many crew members, not because it is extraordinary, because continuity itself becomes precious. Small rituals acquire enormous importance. Birthday songs, shared meals, holiday decorations, stories told before sleep. These simple traditions weave invisible threads through generations. Without them, a spacecraft risks becoming only a machine. With them, it begins resembling a civilization. Perhaps that is why historians often describe culture as humanity's oldest life support system. It preserves identity across time, across disaster, across migration, across oceans. Why should the journey between stars be any different? Yet memory itself changes. Every story retold becomes slightly different. Details soften, new meanings appear. Children ask unexpected questions. Old answers slowly evolve. The Earth remembered after 2 centuries aboard a spacecraft may no longer perfectly resemble the Earth that launched it. Memory is faithful, but never frozen. It breathes, it adapts, just as people do. And while human minds quietly reshape the past, another traveler aboard the vessel experiences time very differently. The computers never grow nostalgic. The sensors never miss sunlight. The machines continue counting, watching, repairing, long after individual lives have ended. Perhaps the silent machines will remember the original mission more accurately than anyone still alive. That possibility leads us toward another unsettling thought. What if the travelers who finally reach Alpha Centauri are no longer the most enduring passengers aboard the ship? Perhaps that honor belongs to the machines that never sleep. Look around your home for a moment. Somewhere nearby, there is probably an object older than you expect. Perhaps it is a wristwatch passed down from a grandparent, a wooden chair built decades ago, a pocket knife carried through generations, an old photograph tucked inside a book. These ordinary objects possess a quiet dignity. They continue existing while the people around them slowly change. They become witnesses, silent companions to lives unfolding around them. Machines have always outlived some of their makers. The pyramids still stand after thousands of years. Ancient Roman roads continue carrying travelers. Medieval cathedrals still gather sunlight through stained glass. Even today, engineers admire structures built by hands long returned to dust. Human civilization has always depended upon creating things that survive longer than individual lives. Interstellar travel demands that idea more completely than anything before it. Imagine a spacecraft beginning its voyage toward Alpha Centauri. The first crew boards with excitement. Children wave goodbye through observation windows. Families exchange final embraces. Engines awaken. The long departure begins. Decades later, the original engineers have grown old. Some have already passed away. The spacecraft continues. Another generation watches its progress through telescopes and radio signals. Then another. Eventually, everyone who witnessed the launch exists only inside history books. The spacecraft remains alive, quietly performing the same tasks, monitoring temperatures, balancing power, correcting its course, opening and closing valves, checking systems that no human hand has touched for centuries. There is something deeply moving about such persistence. Modern spacecraft already offer glimpses of this future. Voyager 1 was launched in 1977. Its designers worked with computers far less powerful than the phone resting quietly inside your pocket today. Many members of the original engineering teams are no longer alive. Yet Voyager still sends faint whispers across billions of kilometers. Each signal travels for more than 23 hours before reaching Earth. When scientists receive those delicate transmissions, they are listening not only to a spacecraft, they are listening to the work of another generation. The machine has become a messenger across time, not merely across space. Voyager teaches an important lesson. Reliability often matters more than complexity. Its systems were designed with extraordinary care, simple where possible, redundant where necessary, graceful under failure. Engineers understood that repair would eventually become impossible, so they focused upon endurance. An interstellar spacecraft must embrace that philosophy even more completely. Every component would require remarkable longevity. Computers, power systems, cooling loops, navigation instruments, communication arrays. Every failure avoided today may preserve lives centuries later. The challenge becomes almost biological. Nature solved a similar problem long ago. Your own body continuously repairs itself. Cells replace damaged neighbors. DNA carries instructions across generations. Bones quietly rebuild throughout your lifetime. The human body survives because maintenance never truly stops. Future spacecraft may need to imitate living organisms rather than ordinary machines. Imagine walls filled with tiny embedded sensors. each continuously searching for microscopic cracks. The moment damage appears, nearby repair systems begin working automatically. No alarm, no emergency, simply quiet healing. Researchers already study materials capable of limited self-repair. Some polymers reconnect after small fractures. Certain experimental materials restore electrical pathways after damage. These technologies remain early in development, yet they point toward an important future: machines that do not merely endure, machines that recover. Artificial intelligence may become another essential companion. Not the dramatic intelligence often imagined in science fiction. Something calmer, more practical. A patient caretaker, monitoring millions of measurements every second, detecting tiny problems long before human eyes could recognize them, adjusting systems continuously, learning subtle patterns, predicting failures before they happen. Recent advances in machine learning have dramatically improved fault detection, autonomous navigation, and spacecraft operations. Modern missions already use increasing levels of onboard autonomy because communication delays make constant human supervision impossible. Future interstellar probes will almost certainly depend upon even greater independence. Yet no existing artificial intelligence has demonstrated the complete autonomy required for centuries-long human interstellar missions. That remains an engineering ambition rather than an accomplished reality. The distinction matters. Science progresses through careful steps, not dramatic leaps. Imagine an old lighthouse standing beside a lonely coastline. Storm after storm passes. Generations of keepers come and go. Ships change. Empires rise and disappear. The lighthouse continues its quiet work, night after night, without applause. A future interstellar computer might resemble that lighthouse. Not glamorous, simply dependable, watching endlessly. There is another remarkable possibility. Machines may remember what humans forget. Human memory changes naturally. Stories evolve, details soften, emotions reshape the past. Computers preserve information differently. Every measurement, every image, every repair log, every decision, stored with extraordinary precision. Suppose a child born aboard the spacecraft asks about the day of launch. No living witness remains. The computer quietly retrieves recordings, voices, videos, instrument readings, even the exact position of Earth in the sky that morning. The machine becomes an archivist, a guardian of origins. Perhaps one day, descendants will know their ancestors through digital memory more clearly than through inherited stories. That possibility feels both comforting and slightly melancholy. Technology preserves facts. People preserve meaning. Neither alone feels complete. Power presents another enormous challenge. Solar panels become increasingly ineffective as the spacecraft leaves the sun behind. Sunlight fades steadily. Engineers therefore examine alternatives. Radioisotope power systems already operate successfully on deep space missions. Nuclear fission reactors are actively being developed for future exploration. Fusion remains a longer-term aspiration. Each approach carries advantages. Each introduces risks. Power is not merely electricity. It becomes warmth, air circulation, water purification, food production, communication, life itself. Turn off the lights inside your home tonight. The silence changes immediately. Now imagine darkness lasting forever. Energy aboard an interstellar vessel is not convenience. It is survival measured in watts. Perhaps the most astonishing machines aboard would never be visible. Tiny pumps, pressure regulators, air filters, valves opening millions of times without failure. The greatest engineering achievements often hide behind ordinary appearances. Your own heart performs roughly 100,000 beats each day, quietly, without celebration, until one day we pause to appreciate the miracle. Machines capable of serving humanity across centuries deserve similar admiration, not because they are perfect, because they remain faithful. Faithful to a mission begun by hands long gone. Faithful to travelers not yet born. Faithful to a destination still invisible beyond endless darkness. And yet, even the finest machine cannot solve every problem. Circuits do not miss home. Algorithms do not wonder about childhood. Computers never gaze through observation windows, searching for familiar constellations. The deepest challenges aboard the voyage remain profoundly human, because eventually, after decades of careful travel, another miracle begins unfolding outside the hull. The tiny point of light ahead slowly grows brighter. The destination that once seemed forever unreachable finally begins taking shape. For the first time, another sun starts becoming more than a distant star. Have you ever walked toward a distant lighthouse at night? At first, its light seems fixed upon the horizon. No matter how long you walk, it barely appears to grow larger. Only after many patient steps do subtle changes begin. The light becomes brighter, its shape grows clearer. What once seemed like a single point slowly reveals windows, stone walls, and quiet details that were always present but hidden by distance. Approaching another star would feel remarkably similar. For most of the voyage, Alpha Centauri would remain little more than an unusually bright point against the surrounding darkness. Years would pass with almost no visible change. Instruments would report steady progress. Computers would continuously refine navigation. Yet, human eyes might struggle to believe movement was happening at all. Space has a peculiar way of disguising motion. On Earth, movement constantly announces itself. Trees slide past a train window. Clouds drift across the sky. Waves break against a shoreline. Even standing still, shadows quietly crawl across the ground as Earth rotates beneath the sun. Between the stars, almost nothing provides such reassurance. The nearest stars are so distant that even enormous changes in position appear painfully slow. Astronomers call this effect stellar parallax. As Earth circles the sun, nearby stars shift ever so slightly against more distant background stars. The effect is extraordinarily small. It required centuries of careful observation before scientists successfully measured it. Imagine extending your arm and holding a single grain of sand between your fingers. Now picture moving several steps sideways. The grain barely changes position against a distant mountain. That tiny shift resembles how nearby stars appear to move when viewed across Earth's orbit. Distance quietly defeats perspective. As the spacecraft continues forward, Alpha Centauri slowly begins revealing its true nature. It is not one star, it is a family. The system contains 3 known stars: Alpha Centauri A, Alpha Centauri B, and the smaller companion known as Proxima Centauri. Alpha Centauri A resembles our own sun in many important ways. Slightly larger, slightly brighter, slightly older in some estimates. It shines with a warm yellow-white light that would feel strangely familiar to human eyes. Beside it travels Alpha Centauri B, a little smaller, a little cooler. Its light carries a gentle golden-orange tone. The 2 stars orbit one another in a graceful celestial dance lasting nearly 80 years. Sometimes they draw relatively close together. At other times they drift much farther apart. Gravity patiently guides every movement. Neither star truly leads, neither truly follows. They simply share the journey. Far beyond them circles Proxima Centauri, small, red, quiet. It is a red dwarf, far dimmer than either of its larger companions. Despite being the closest individual star to Earth, it would be difficult to notice with the naked eye if viewed from our own planet without powerful instruments. Size often hides behind proximity. Imagine watching 2 experienced dancers moving across a silent stage. Their steps appear effortless. Each movement anticipates the next. Neither collides, neither escapes. Gravity performs a similar choreography on scales beyond imagination. Every orbit reflects countless millions of years of quiet balance. Recent observations continue refining our understanding of this nearby stellar family. Precise measurements from observatories on Earth and in space have improved estimates of stellar masses, orbital behavior, and ages. These refinements strengthen our confidence in Alpha Centauri as one of the best understood neighboring systems. While details continue improving, the overall picture remains remarkably stable. Sometimes scientific progress resembles polishing an old lens. The landscape does not change, only our ability to see it. As the spacecraft approaches, another remarkable transformation begins. The familiar constellations slowly dissolve. From Earth, Orion appears timeless. The Southern Cross guides navigators. The Big Dipper faithfully circles the northern sky. We often imagine these patterns as permanent. They are not. Constellations exist only because humanity observes them from one particular location. Move near enough through space. Every familiar pattern breaks apart. The hunter loses his shape. The bear disappears. Ancient myths dissolve into scattered points of light. The night sky itself acquires a new identity. Imagine returning to your childhood home after decades away, only to discover that every road has been rearranged. The buildings remain, the people remain, yet the map no longer matches memory. Approaching Alpha Centauri would produce that same quiet disorientation. The heavens would no longer resemble the heavens of Earth. Home would literally disappear from the sky. Our own sun, once the overwhelming center of human existence, would become another ordinary star among thousands. Bright enough to identify with careful instruments, far too faint to provide warmth. Travelers might point toward it during educational lessons for children born aboard the vessel. There, that tiny star, that is where our story began. The sentence would carry enormous emotional weight. Yet visually, it would describe almost nothing, one tiny point among countless others. Perspective transforms importance. Earth teaches us to think of the sun as unique. Alpha Centauri quietly reminds us that every civilization likely feels the same about its own star. Each sun becomes the center of someone's sky. Yeah. Perhaps that realization nurtures humility. We often speak of our universe, our solar system, our neighborhood. Yet every star possesses its own quiet center, its own gravitational family, its own history unfolding without witness. The spacecraft now enters the stage where navigation becomes increasingly delicate. During the long cruise through interstellar darkness, small trajectory corrections accumulated gradually. Now, every adjustment matters more. Passing too close to one star may complicate future maneuvers. Passing too far wastes precious energy. Gravity becomes both opportunity and responsibility. Imagine steering a canoe toward a narrow opening between two gentle currents. Tiny movements determine everything. Future mission planners continue studying how best to approach the Alpha Centauri system under different propulsion concepts. Some proposed missions would perform high-speed flybys, gathering observations during only a few brief hours. Others imagine advanced braking systems capable of entering orbit. Those concepts require technologies humanity does not yet possess operationally. Slowing down often proves more difficult than speeding up. Every arrival hides another challenge. You cannot truly explore a place while rushing past it, yet stopping requires tremendous energy. The stars quietly demand patience once again. Ahead, questions begin replacing distance. Are there planets? Could oceans exist? Might clouds drift beneath another sun? Or will the travelers discover only silent worlds, shaped by rock and time? The journey that began as a struggle against distance now becomes something entirely different. A search for places where life might someday find another home. Imagine standing on a quiet hill just before sunrise. The landscape ahead remains hidden beneath soft darkness. You know fields, rivers, and distant towns are there, yet your eyes cannot quite separate one shape from another. Then, almost imperceptibly, the first light arrives. Details begin emerging. A single tree appears, a winding road, the outline of a distant farmhouse. Nothing new has been created. The light has simply revealed what was already waiting. Astronomy often advances this way. The universe rarely surprises us by suddenly inventing new worlds. Instead, our instruments become patient enough to notice them. For centuries, Alpha Centauri was simply 3 stars shining together in the southern sky. Sailors used them for navigation. Astronomers carefully measured their motions. Physicists calculated their masses. Yet one question quietly lingered through every generation. Do other worlds circle those nearby suns? The question sounds wonderfully simple. The answer has proven remarkably difficult. Finding planets around distant stars resembles trying to spot a tiny firefly circling an enormous lighthouse from thousands of kilometers away. The lighthouse overwhelms your vision. The firefly disappears inside its brilliance. The planet does not need to be especially small. The star is simply unimaginably bright. Imagine placing a single grain of rice beside a powerful searchlight. The rice still exists. The light simply refuses to let you see it. That is the challenge astronomers confront whenever they search for exoplanets. Fortunately, nature provides several gentle clues. Sometimes a planet passes directly in front of its star. The starlight dims ever so slightly. Sensitive telescopes detect that tiny decrease. Sometimes a planet's gravity causes its star to wobble almost imperceptibly. Precision instruments measure that subtle motion. Occasionally, under extraordinarily favorable circumstances, astronomers can directly image the planet itself by carefully blocking the overwhelming glare of the parent star. Each method resembles listening for whispers beside a waterfall. Progress comes slowly, patiently, one careful observation after another. The Alpha Centauri system has become one of astronomy's most compelling laboratories because it is so close. At only about 4.37 light-years away, it is our nearest stellar neighbor. If another planetary system ever becomes humanity's first interstellar destination, Alpha Centauri remains among the strongest candidates. That possibility makes every new observation precious. The smallest discovery carries enormous weight. Around Proxima Centauri, the faint red dwarf companion, astronomers have already confirmed several planets. The most famous is Proxima Centauri b. It possesses roughly Earth's mass and orbits inside what astronomers call the habitable zone, where temperatures could, under suitable conditions, allow liquid water to exist on a planetary surface. That does not mean the planet is known to be habitable. Proxima Centauri is an active red dwarf that frequently releases powerful stellar flares capable of bombarding nearby planets with intense radiation. Whether such a world could truly support life remains an open scientific question. Observation, not certainty. Hope, not proof. Science advances most reliably when those distinctions remain clear. The larger stars, Alpha Centauri A and Alpha Centauri B, have presented an even greater challenge. Their combined brightness and close orbital dance make planetary searches exceptionally difficult. For many years, astronomers found intriguing hints, but no confirmed planets. Then modern telescopes became more capable. The James Webb Space Telescope began examining the system with extraordinary sensitivity. Using its mid-infrared instrument, combined with sophisticated image processing techniques that suppress overwhelming starlight, astronomers identified the strongest evidence yet for a giant planet orbiting Alpha Centauri A. The object appears consistent with a Saturn-sized gas giant traveling through the star's habitable zone. Yet scientists remain deliberately cautious. Follow-up observations in 2025 did not detect the object again, and computer simulations suggest it may simply have moved too close to the star's glare to remain visible during those observations. For now, it remains a promising planet candidate rather than a confirmed discovery. Additional observations will determine whether this nearby world truly exists. There is something wonderfully humble about that conclusion. Astronomers did not announce victory. They announced uncertainty. Uncertainty often disappoints headlines. It delights science. Because uncertainty invites another observation, another calculation, another quiet night beneath the stars. Suppose the candidate is eventually confirmed. It would almost certainly not resemble Earth. Current evidence suggests a giant world, composed primarily of hydrogen and helium. Such a planet would not offer a solid surface where forests could grow or rivers might flow. Yet giant planets often possess families of moons. Within our own solar system, Jupiter and Saturn remind us that moons can become fascinating worlds in their own right. Europa hides an ocean beneath ice. Titan carries rivers of liquid methane. Enceladus sprays water into space. The lesson is gentle. Sometimes the most interesting destination is not the planet itself, but the companions traveling beside it. Whether Alpha Centauri's possible giant planet possesses moons remains completely unknown. The silence continues. Imagine approaching the system after decades of travel. Your telescopes no longer examine tiny points of light. Cloud systems become visible. Planetary disks slowly separate from the surrounding darkness. Perhaps rings shimmer faintly beneath another sun. Perhaps moons drift quietly through enormous shadows. Perhaps nothing resembles the expectations carried from Earth. Exploration has always rewarded curiosity more generously than certainty. Recent astronomy repeatedly demonstrates this pattern. Each improvement in telescope sensitivity reveals more complexity rather than less. Planetary systems prove astonishingly diverse. Some contain giant planets hugging their stars. Others possess compact families of rocky worlds. Some appear strangely chaotic, others remarkably orderly. Nature seems unwilling to repeat herself exactly. Perhaps that is one reason the night sky never grows old. Every nearby star quietly asks a different question. Every new observation reshapes the map just a little. Yet one profound uncertainty still remains untouched. Even if planets exist, even if some possess oceans, even if chemistry proves favorable, would any of those distant shores ever have witnessed life awakening beneath another sunrise? That question has waited patiently since humanity first looked upward. It still waits today. Imagine stepping onto a beach you have never visited before. The sand feels familiar beneath your feet, yet every detail is quietly different. The waves carry another rhythm. The wind smells unfamiliar. Birds call with voices you have never heard. For a few peaceful moments, your mind does something remarkable. It searches for similarities before accepting differences. Every new place is first understood through memories of old ones. If humanity ever reached Alpha Centauri, we would almost certainly do the same. We would compare every horizon with Earth, every mountain with mountains we already know, every cloud with clouds remembered from childhood. The human mind builds bridges before it accepts new worlds. Suppose the long voyage has finally ended. The spacecraft has survived. Its descendants have grown old. Its machines have remained faithful. Outside the observation windows, an unfamiliar planetary system slowly fills the sky. No one aboard has ever stood beneath another sun. Yet everyone has dreamed about this moment. The first challenge would not be landing. It would be choosing where to land. Astronomers on Earth spend years studying possible landing sites on Mars using orbiters, radar, and high-resolution imaging. Every slope matters. Every boulder, every dust field. Now imagine making similar decisions for a planet that has never been visited by any human machine. Every calculation carries enormous weight. There are no second chances. Imagine lowering a small exploration vehicle through an unfamiliar atmosphere. If an atmosphere exists, the descent begins gently. Heat builds outside the protective shell. Sensors awaken one after another. Pressure rises. Wind speeds fluctuate. Cloud layers appear. The world slowly introduces itself. Every measurement becomes history. Perhaps the atmosphere proves thin, perhaps dense, perhaps composed mostly of nitrogen, perhaps rich in carbon dioxide, perhaps something entirely unexpected. Science must always allow nature the final word. Even the color of the sky remains uncertain. On Earth, our sky appears blue because molecules in the atmosphere scatter shorter wavelengths of sunlight more efficiently than longer ones. Change the atmosphere, change the star, change the suspended particles. The sky changes with them. A world orbiting a red dwarf may experience lighting unlike anything familiar on Earth. A planet beneath Alpha Centauri, A could feel more recognizable. A world around Alpha Centauri B might possess warmer golden daylight. Every sunrise would carry its own personality. Imagine taking the first careful step onto alien soil. Not dramatic, not triumphant, simply careful. Your boot presses gently into unfamiliar ground. Tiny grains shift beneath your weight. Dust rises slowly. For the first time in history, human footprints appear beneath another star. The moment would belong not only to explorers, but to every generation that quietly carried the dream across centuries. The landscape itself might appear surprisingly ordinary. Rock, hills, valleys, perhaps frozen lakes, perhaps ancient volcanic plains, perhaps endless deserts. Mars taught us an important lesson. An alien world does not need towering crystal mountains or glowing forests to inspire awe. Sometimes ordinary geology beneath an unfamiliar sky is extraordinary enough. Scientists would immediately begin asking careful questions. How old are these rocks? How much water once existed here? What minerals formed beneath ancient ocean? How active is the planet's interior? Every stone becomes a page from another world's history. Imagine picking up a small rock. To your eyes, it resembles thousands collected on hiking trails back home. Yet its atoms formed around another star. Its chemical story unfolded entirely outside the solar system. You are holding matter that spent billions of years beyond humanity's reach. The ordinary becomes astonishing. If liquid water exists, attention would naturally turn toward it. Water remains one of the most important ingredients for life, as we understand it. Rivers, lakes, subsurface oceans, even temporary seasonal flows. Each possibility deserves careful investigation. Yet water alone does not guarantee biology. Venus once may have possessed oceans. Today, it does not. Europa almost certainly hides a vast ocean beneath ice. Whether life exists there remains unknown. Nature rarely rewards simple assumptions. Recent planetary science continues reinforcing this lesson. Every new mission inside our own solar system reveals greater complexity than expected. Mars preserves evidence of ancient rivers. Europa continues showing signs of a deep internal ocean. Titan possesses lakes unlike anything on Earth. These discoveries encourage optimism, while also reminding scientists that habitability and inhabited are not identical ideas. A world may welcome life without ever producing it, or life may arise in forms we have not yet imagined. Imagine finding no life at all, no plants, no animals, no microorganisms, only silent landscapes beneath unfamiliar constellations. Would the journey still matter? Perhaps more than ever, because absence also teaches. A lifeless world reveals which ingredients were missing, which conditions failed, which pathways nature did not follow. Silence carries information. Astronomers have learned this repeatedly. A telescope detecting nothing still improves understanding. An experiment disproving an idea still advances knowledge. Failure often removes one more wrong answer. That quiet honesty defines science. Now imagine the opposite. Not cities, not intelligent civilizations, only the faintest microscopic cells drifting through shallow water. The discovery would forever transform humanity. Every religion, every philosophy, every scientific discipline, every history book. Life would no longer belong exclusively to Earth. The universe would suddenly feel both larger and more intimate. Yet current evidence provides no confirmation of life anywhere beyond our own planet. Not around Alpha Centauri, not elsewhere. The search continues, patiently, methodically, without certainty. Perhaps that restraint makes the search even more beautiful, because hope remains guided by evidence, not by wishful thinking. As explorers continue surveying their new world, another realization quietly settles upon them. They have succeeded beyond the dreams of countless generations. Yet the greatest distance may no longer separate them from Earth. It may separate them from conversation itself. For even standing beneath another sun, every message home must still cross the same immense darkness. And light, faithful as always, will never travel faster than it already does. Imagine sending a simple message to someone you love. You type a few words, perhaps only 3. I'm home safely. You press send. Within seconds, a reply appears. Another few moments pass. The conversation continues almost effortlessly. Modern life has quietly erased the feeling of waiting. Information crosses continents almost instantly. Satellites relay signals through space. Fiber optic cables carry light beneath oceans. Distance still exists. But communication has learned to outrun nearly every ordinary inconvenience. Interstellar space refuses that luxury. No technology known today can send information faster than light. This is not merely an engineering limitation. It is one of the deepest principles modern physics has repeatedly confirmed. Every radio transmission, every laser pulse, every digital photograph, every whispered farewell encoded into electromagnetic waves must obey the same universal speed limit. Light is astonishingly fast, yet the stars are astonishingly farther. Suppose the first explorers finally establish a permanent settlement somewhere within the Alpha Centauri system. They carefully assemble a powerful communication array. The antennas align with exquisite precision. A transmitter awakens. Engineers prepare the first message ever sent home from another star. The words are simple. We have arrived. The signal leaves immediately. Nothing delays its departure. It races across the darkness at 300,000 kilometers every second. It never slows. It never hesitates. Yet Earth waits more than 4 years before hearing those 3 quiet words. By then, the people who transmitted them have already lived another 4 years. Perhaps children have been born. Perhaps elders have passed away. Perhaps entire seasons have quietly come and gone beneath another sun. The message describes a past that no longer exists. Every conversation becomes history before it is heard. Imagine asking Earth a question. How is everyone? Your message departs. 4 years pass. Earth receives it. Someone carefully writes a reply. Another 4 years pass. Nearly 9 years separate your question from the answer, arriving back. An ordinary conversation has become almost a decade long. The emotional consequences are difficult to overstate. Birth announcements arrive years after the child begins school. Wedding congratulations reach couples whose anniversaries have already passed. Condolence messages may arrive long after mourning has quietly softened. Every relationship becomes an archive, not because affection fades, because physics quietly stretches every human connection. Letters once crossed oceans aboard sailing ships. Families sometimes waited months for news. Interstellar communication extends that experience beyond anything previous civilizations ever imagined. Patience becomes the language of love. Imagine a grandfather on Earth recording stories every birthday for a granddaughter born during the voyage. Every year he sits before a camera. He smiles gently. He speaks about changing seasons, family memories, simple advice. The recordings travel one after another across the darkness. The granddaughter watches them, not as live conversations, but as a slowly unfolding autobiography. She meets the younger version of a man already growing old, then older still. Eventually, one recording arrives carrying no new message afterward. The silence itself becomes the final chapter. Distance quietly transforms time into memory. Science has explored several imaginative ideas for faster-than-light communication. Concepts involving wormholes, quantum phenomena, and other speculative physics often appear in fiction and theoretical discussions. Yet, no verified experiment has demonstrated a method for transmitting usable information faster than light. Quantum entanglement, despite its remarkable properties, does not permit faster-than-light messaging according to current scientific understanding. The limitation remains one of the most firmly established results in modern physics. Reality often proves more patient than imagination. Perhaps that patience teaches something valuable. On Earth, we sometimes answer messages without reflection. We respond immediately. Emotion first, thought later. Interstellar correspondence would encourage something entirely different. Every message becomes precious, every sentence carefully chosen, every word expected to survive years of travel. Imagine composing a letter, knowing the reader will encounter it nearly a decade after you began writing. Would you complain about small inconveniences, or would you speak about deeper things? Perhaps conversations would become calmer, more deliberate, more honest. Distance might quietly improve wisdom, not because people become smarter, because urgency gradually disappears. The explorers would also receive Earth's history in slow motion. Scientific discoveries, political changes, new music, new literature, entire generations of culture drifting steadily across the darkness. By the time one technological breakthrough reached Alpha Centauri, another might already be transforming life back home. The settlement would always experience Earth slightly behind the present. Earth would experience Alpha Centauri the same way. Neither civilization could truly live in the other's now, only in each other's yesterday. Imagine two clocks mounted on opposite sides of a wide valley. Each keeps perfect time, yet every sound echoes across the distance with long delay. Neither clock is wrong. The valley simply refuses immediate conversation. Interstellar space becomes that valley, only unimaginably larger. Future engineers may build extraordinarily powerful laser communication systems. Narrow beams could carry enormous amounts of information efficiently across interstellar distances. Sophisticated error correction methods would preserve data despite the immense journey. These technologies appear increasingly feasible in principle, yet even perfect engineering cannot shorten the travel time imposed by light itself. The signal may become clearer. It cannot become faster. Perhaps that realization carries unexpected beauty. Every message crossing the stars becomes an act of faith. You speak without knowing exactly who will receive your words. You trust that someone, years from now, will still be listening. In many ways, that resembles history itself. Authors write books they will never see future generations read. Parents teach lessons whose greatest influence appears decades later. Gardeners plant trees beneath whose shade strangers eventually rest. Human life has always contained quiet acts of delayed hope. The stars merely stretch those delays farther than ever before. And yet, after years of patient correspondence, another truth slowly becomes impossible to ignore. The explorers may continue speaking with Earth. Earth may continue answering, but neither place remains the same. Time keeps moving. Children become elders. Civilizations evolve. Cultures slowly diverge. Eventually, the greatest separation is no longer measured in light years. It is measured in experience. The people beneath another sun have begun becoming something gently different. A new branch of humanity, growing quietly beneath unfamiliar skies. Imagine returning to the house where you spent your childhood. The streets seem smaller than you remembered. The trees have grown taller. A familiar shop has disappeared. New buildings stand where empty fields once stretched toward the horizon. You recognize almost everything, yet nothing feels exactly the same. Home has continued living while you were away. Now imagine returning after not 20 years, not 100, but several centuries. The distance would no longer be measured by kilometers. It would be measured by history. That is the quiet truth waiting at the end of an interstellar journey. The greatest challenge is not reaching Alpha Centauri. The greatest challenge may be coming back. At first, the idea appears wonderfully simple. If humanity can travel to another star, surely it can reverse the engines and fly home again. Physics offers a gentler answer. Every kilogram accelerated toward another star must eventually be slowed again. Every burst of energy required for departure must be matched by another for arrival. A return journey demands the same impossible endurance all over again. The spacecraft does not simply retrace its path. It begins another voyage almost equal to the first. Imagine climbing an enormous mountain. After reaching the summit, you discover that the descent requires as much care as the climb. Every careless step still carries consequences. The journey home becomes another expedition entirely. Fuel quickly becomes the first obstacle. A spacecraft carrying enough propellant for departure. Arrival. Departure again. And final arrival grows dramatically heavier. More mass requires more energy. More energy demands larger engines. Larger engines require more structure. More structure adds still more mass. Engineers call this the tyranny of the rocket equation. Its mathematics remain elegant. Its consequences remain unforgiving. Future propulsion concepts hope to escape some of these limitations. Fusion engines might gather extraordinary energy from compact fuel. Beamed propulsion could accelerate spacecraft without carrying every source of power on board. Concepts involving magnetic sails propose slowing a spacecraft by interacting with charged particles in interstellar space rather than relying entirely upon onboard fuel. These ideas continue inspiring research. None has yet carried humans between the stars. Every promising solution still asks difficult questions. Suppose. However, that technology eventually overcomes every engineering challenge. The engines work. The spacecraft survives. The long voyage home begins. What exactly waits upon arrival? Imagine departing Earth in the year 2200. Your journey requires 2 centuries. You return during the year 2600. Every person who waved goodbye has vanished into history. Every government has changed. Languages have evolved. Cities have transformed. Music sounds unfamiliar. Customs feel strangely distant, even if the continents remain recognizable. Civilization itself may not. The travelers become visitors from another age. History offers quieter versions of this experience. Sailors once departed for voyages lasting years. They returned to children who had become adults. Explorers crossed oceans and discovered kingdoms transformed by politics they never witnessed. Immigrants revisited villages that no longer remembered their names. Time has always changed home. Interstellar distance simply magnifies the transformation. Imagine opening an old wooden chest inside the returning spacecraft. Carefully preserved photographs remain inside. Letters, maps, small toys, perhaps a handful of soil collected from Earth before departure. To the returning crew, these objects are memories. To future generations waiting on Earth, they have become archaeological treasures. Ordinary possessions quietly transform into historical artifacts. The same change happens in reverse. The Earth awaiting the travelers possesses inventions beyond their experience, medical knowledge unimaginable at departure, new forms of art, new philosophies, perhaps even new branches of humanity adapted to environments throughout the solar system. The returning explorers become immigrants inside their own birthplace. There is something deeply moving about that possibility. Home never rejected them. Home simply continued growing. Recent astronomy often reminds us that the universe itself behaves similarly. Stars evolve while we watch. Galaxies slowly merge across billions of years. Planetary systems change as their stars age. Nothing remains perfectly fixed. Stability itself often proves temporary when viewed across long enough timescales. Perhaps permanence has always been an illusion created by short human lives. Imagine standing once more beneath Earth's sky after centuries away. The moon still rises, the sun still warms your face, rain still carries its familiar scent, yet your memories belong to another civilization. The children surrounding you learn different histories, different songs, different heroes. They welcome you warmly, but they cannot truly share your past. You have become living history, a bridge between eras. Some philosophers have suggested that every great journey changes the traveler more than the destination. Crossing another ocean transforms perspective. Climbing a mountain changes the climber. Living beneath another sky reshapes identity. Interstellar travel represents the greatest expression of that ancient truth. No one truly returns unchanged. Perhaps no one truly returns at all. Because the person who comes home is never exactly the person who left, nor is the home exactly the same place. There is another possibility. Perhaps humanity never intends to return. Many proposed concepts for future interstellar settlement quietly accept this reality. Rather than imagining repeated voyages between stars, they imagine new civilizations taking root independently. Earth becomes the place of origin rather than the permanent center. Alpha Centauri becomes another beginning instead of a distant outpost. A tree offers a gentle metaphor. Its oldest roots remain deep within familiar soil, yet every branch reaches toward new sunlight. The branch does not betray the roots, it fulfills them. Perhaps civilizations grow the same way, not by remaining forever where they began, but by extending carefully into places once beyond imagination. If humanity someday establishes communities around another star, Earth will not become less important. It will become something even more profound, the birthplace of every story told beneath every future sun. That thought softens the sadness of departure, because leaving home is not always abandoning it. Sometimes it is the highest form of remembering. As our long journey approaches its final quiet chapter, one question remains: why undertake such an impossible voyage at all? Why spend centuries crossing darkness that seems determined to resist us? The answer lies beyond engineering, beyond astronomy, beyond even Alpha Centauri itself. It waits inside the oldest habit our species has ever possessed: the quiet desire to look toward the horizon and wonder what waits beyond it. There is a quiet moment that arrives at the end of every long journey. You set down your bag. You close the door behind you. The world grows still. For the first time, you realize that the destination mattered less than the person who completed the road. Mountains remain where they always stood. Oceans continue meeting their shores. Cities continue breathing through countless ordinary mornings. The greatest transformation happens somewhere inside you, almost too gently to notice. Perhaps Alpha Centauri was always meant to teach the same lesson. For thousands of years, humanity looked upward without knowing what those tiny lights truly were. Ancient civilizations imagined divine fires, celestial kingdoms, or eternal lamps suspended above the earth. Their interpretations differed, yet their instinct remained remarkably consistent. They wondered. That simple habit became one of our greatest inheritances. Curiosity quietly survived every empire, every language, every generation. It crossed deserts, it sailed oceans, it climbed mountains. Eventually, it built telescopes, then rockets, then machines capable of leaving the solar system itself. Every achievement began with the same quiet question: what is out there? The answer has never been simple. Each discovery solved one mystery while revealing 10 more waiting patiently beyond it. The Earth turned out not to be the center of the cosmos. The Sun became one ordinary star among hundreds of billions inside the Milky Way. The Milky Way itself became one galaxy among hundreds of billions more. Modern observatories continue extending that horizon. The James Webb Space Telescope has revealed galaxies shining from astonishingly early periods in cosmic history. Astronomers continue refining models of galaxy formation, stellar evolution, and planetary systems. Many recent discoveries have not overturned the foundations of astronomy. Instead, they have enriched them, revealing that the universe is often more intricate than our previous models suggested, rather than fundamentally different. Knowledge rarely closes the book. It simply turns another page. Alpha Centauri occupies a special place within that story, not because it is the brightest star, not because it is the largest, not because it certainly hosts another Earth. Its importance comes from something quieter. It is close enough to imagine reaching. For the first time in history, humanity can seriously discuss another stellar system not as mythology, but as a future destination worthy of scientific planning. That distinction changes us. Imagine children looking through a telescope a century from now. They may not see only distant lights. They may see tomorrow's frontier. The same way earlier generations once looked westward across unknown oceans, or upward toward the moon before the first footprints appeared there. Every civilization possesses a horizon that seems unreachable, until one day it no longer is. History repeatedly reminds us that impossible journeys gradually become ordinary ones. Crossing the Atlantic once demanded extraordinary courage. Today, millions do it without a second thought. Flying across continents once seemed miraculous. Now it feels routine. Walking upon the moon belonged to fiction, until it belonged to history. Interstellar travel remains far beyond our present capabilities. Science says so honestly. No verified propulsion system can yet carry humans to Alpha Centauri within practical timescales. No operational life support system can preserve a civilization through centuries of uninterrupted flight. No confirmed technology allows faster than light travel. Reality remains patient, yet history quietly encourages humility. not because every dream eventually succeeds, but because the boundary separating imagination from engineering has moved before, many times. Perhaps it will move again, perhaps it will not. Science accepts either outcome because its loyalty belongs to evidence rather than desire. There is wisdom in that restraint. Throughout tonight's journey, we have crossed astonishing distances without leaving our chairs. We stepped across an ordinary room. We measured light years. We drifted beyond the heliosphere. We entered the silent darkness between stars. We imagined generation ships carrying descendants who had never seen rain. We watched Alpha Centauri slowly separate into its 3 quiet suns. We considered distant planets, uncertain atmospheres, and the possibility that life may or may not have awakened beneath unfamiliar skies. We listened to messages taking years to cross the darkness. We returned to an Earth transformed by centuries. Every stage revealed another truth. Distance is never merely physical. It is emotional, historical, philosophical. Imagine looking back one final time. From somewhere near Alpha Centauri, the sun has become another bright point among thousands. Earth cannot be seen with unaided eyes. Every language ever spoken, every poem, every painting, every war, every act of kindness, every farewell, every lullaby, every heartbeat in human history, all belong to a tiny world now hidden inside one invisible point of light. That realization does not make humanity feel insignificant. Quite the opposite. It reveals how astonishingly much meaning can exist inside something so small. The universe measures greatness differently from people. Stars are measured by mass, galaxies by size, time by billions of years. Human lives are measured another way, by memory, by compassion, by curiosity, by the willingness to ask questions whose answers may never arrive during our own lifetimes. Perhaps that is why the stars continue calling to us, not because they promise easy answers, because they invite better questions. Recent astronomical discoveries continue reminding us that the nearest stars still hold many secrets. Researchers continue observing Alpha Centauri with ever more capable instruments. They continue searching for planets, refining orbital models, studying stellar activity, and testing ideas that only a generation ago seemed impossible. Some observations strengthen long-standing theories. Others introduce careful new possibilities. None diminish the mystery. They simply make it more precise. Precision is one of science's quiet forms of wonder. It replaces fantasy without replacing awe. And so the horrifying journey to Alpha Centauri reaches its gentle end, not because every mystery has been solved, but because we have learned to appreciate the silence between the answers. Tonight, perhaps the night sky will appear slightly different. The brightest stars may no longer seem like decorations scattered across darkness. Instead, they may resemble distant homes still waiting to introduce themselves, patiently, across oceans without water, across years carried by light, across a darkness that is never truly empty. If humanity someday reaches Alpha Centauri, it will not be because we conquered the universe. It will be because we never stopped listening to it. And perhaps that has always been the real destination. Not another star, but a deeper understanding of the small blue world that first taught us to look upward. As the night grows quieter, the stars continue their ancient work. They burn, they drift, they wait, and somewhere, more than 4 years away at the speed of light, Alpha Centauri is shining exactly as it was when this evening began. Its newest light is still traveling toward us, silent, patient, unhurried, just as it always has.